What's today? The 4th. And we are going to be solving quadratic systems today. So solving quadratic systems. And what you're going to be doing is you're going to be given like an equation of a line and an equation of a parabola. And when you solve a quadratic system, you're basically finding out where the line and the parabola intersect with each other. Okay? Now, you can do that by graphing, but sometimes it's not real accurate. And you can also do it by substitution, which is extremely accurate. So what we're going to do today is we're going to solve some of these quadratic systems. We're going to use substitution, and we're just going to use really what is almost like a manipulation technique. So today we are going to, let's see, what is the solution? Here's how the question will be asked. What is the solution of the system of equations? And here's the system. Y equals negative x squared minus x plus 6. And the other equation is y equals x plus 3. So the first equation is a parabola, and the second equation is a line. And what we're finding out here is where the line and the parabola intersect each other. So, I mean, if you had a coordinate plane and you graphed these two, you know, your parabola, this has a negative a, so this thing's going down. So you may have something that looks like this. And then your line is going up and to the right, and it hits y at positive 3. So this is probably a bad example I'm giving you here. So let's just solve this thing. All right. We need to solve for x and y. So look, first of all, if y is equal to negative x squared minus x plus 6, and y is also equal to x plus 3, you can take this x plus 3 and you can write it in the top equation where the y is, because that's what y is equal to. So if you rewrite this thing as x plus 3 equals negative x squared minus x plus 6. That's what you got. Now, we're going to get everything on one side of the equation. So we're going to subtract x, and we're going to subtract 3 from both sides of the equation. So subtract x, subtract 3, so we got to subtract x, and we got to subtract 3. So on the left-hand side of the equation, your x minus x is 0, your 3 minus 3 is 0, you get a 0 over there. On the right-hand side of your equation, you get negative x squared. Negative x minus x, that's a negative 2x. And then you got a positive 6 and a negative 3, and that gives you a positive 3. That's a positive 3. So now, since you've got a negative sign in front of the x squared, we're going to get rid of that next. We're going to divide both sides by -1. So on the left-hand side, we get a 0. And what dividing this right side by -1 does, is it changes the sign of everything on the right-hand side. So we get x squared, we get positive 2x, and we get -3. And now you're solving a quadratic. And you've done that for the last couple of weeks. And some of the techniques you used to solve a quadratic was you factored or you used the quadratic formula. You also did complete the square. You did a bunch of different techniques. But in this case right here, this trinomial or this quadratic, you can factor that pretty simple, because what you got here is an x and an x. And you're looking for two numbers that multiply to 3 but add to 2. So I'm thinking a 1 and a 3. So if I go a 1 and a 3, all right, since my 2 needs to be positive in the middle, then my larger number needs to be positive. My larger factor, 3, needs to be positive, and the 1 needs to be negative. So we got -1 times 3 is -3. Got -1 plus 3 is the 2. So those are our correct factors. So now what you do is you take each factor and set it equal to 0. So you take your x minus 1 equals 0, and you make your x plus 3 equal to 0. You solve for your two x's. All right, now you're almost finished. Now what you do is you input each x. And I'm going to input it into this equation right here, because that's simple. All right, and you find the y value when x equals 1, and you find the y value when x equals -3. All right, so you've got a y equals 1 plus 3, and you've got a y equals -3 plus 3. So when x equals 1, y equals 4. So there's one of your solutions. 1, 4. Then you solve for y when x is equal to -3. So y would be equal to 0. So when x equals -3, y is equal to 0. And those are your two solutions for that system of equations. Any questions on any of those steps? Or anybody need to see another one? You basically substitute, factor, solve, substitute again, and get your x and y values. So the second type of problem you're going to see in your assignment today will look like this. And again, you're finding the solution to the system. So now we got y equals -x squared. Minus x plus 12. And then y equals x squared. Plus 7x plus 12. So now you've got two parabolas that intersect each other. So your technique is pretty much the same as the last problem. All right. If y equals negative x squared minus x plus 12 and y equals x squared plus 7x plus 12, you can replace the y up top with what y is equal to. So if you take this now and you take x squared plus 7x plus 12, you set it equal to negative x squared minus x plus 12. If you take the whole right side of the equation, we're going to try to get this thing equal to 0. So watch. On this right-hand side, if we add x squared and we add x and we subtract 12, and then do the same thing to the left side. If you add x squared and you add x and you subtract 12, what you get is x squared plus x squared is 2x squared. You get 7x plus x, which is 8x. Your 12 minus 12 is 0. That goes away. And everything on the right-hand side zeroes out. So there's what you're left with. 2x squared plus 8x equals 0. And again, now you can solve by factoring. So 2x squared and 8x both have a 2x in them. So if you pull out a 2x, then inside the parentheses, you're going to get an x plus 4. And that equals 0. So now you set your two factors equal to 0. So your 2x is equal to 0. And your x plus 4 equals 0. If you divide both sides by 2, here we get an x value of 0. And if you subtract 4, get an x value of negative 4. And now you take both of those, or each of those individually, and you substitute them into one of the equations and you solve for y. So I'm going to substitute into this bottom equation. So I'm going to get y equals 0 squared plus 7 times 0 plus 12. So y is equal to 12 when x is equal to 0. So there's your first solution. That's 0 for x, 12 for y. Then you substitute the negative 4. So your y would be equal to negative 4 squared plus 7 times negative 4 plus 12. So your y when x is equal to negative 4 would be 16 minus 28 plus 12. And 16 minus 28 plus 12. 16 minus 28 is negative 12 plus 12, that would be 0. All right, so your second solution is when x is equal to negative 4. When x equals negative 4, y is equal to 0. So those are the 2 points on the coordinate plane where the parabolas intersect each other. All right, anybody have any questions on either of those types of problems? Parabola intersecting a line or a parabola intersecting a parabola? All right, then your assignment for today I need you to do this on a clean sheet of paper. You're going to put it in the basket when the bell rings. You got page 262? (14 through 25). On a clean sheet of paper. So if you're in class, you put it in the basket when the bell rings. If you're a Zoom student, you're going to email me a picture. Okay, everybody understand what the assignment is for today? Does anybody have any questions on the assignment for today? All right, then you Zoom guys are excused and can get to work on the assignment. As soon as you get it finished, send me a picture, please.